functions, the sine, cosine, tangents that I have on the back board, is when we have a 90-degree angle inside of our triangle. Yeah, there's a limit. So we're going to use sine law when we have an oblique triangle. So an oblique triangle doesn't contain a right angle and has a whole smattering of other angles in it. An acute triangle, again, there's no 90 degree in here. They're all smaller than 90 degrees. What do you volunteer angles that up to in a triangle? 180 degrees. So you need to know that so you save you some time. What are you doing with your phone? Obtuse triangle. So obtuse triangle has one interior angle that's greater than 90. I don't know if they put a classifying triangle question on your exam, but they might ask you something like, what trig ratio would you use, or how would you solve this? They give you a word question where they're asking you how you solve it. So you have to say, oh, I use sine law because there's no 90-degree angle, or it's an acute triangle, and I can't use regular trig ratios. So they might ask you a question like that. And if you use fancy words like oblique, acute, or obtuse, you're probably going to nail the 2-mark question for these. And these swim ones are hard because you've got to use words, and you kind of have to nail it on the head. You got to know your stuff. So when you guys had that explain question on your test that talked about somebody was in the 90th percentile, but they still didn't like their test mark, why would this be? Like, that's a question from the exam. And so what I was looking for was a very specific answer, and that's why you would discipline something you haven't written it yet. So I'll stop talking. All right, so in this triangle, oh, I should also say, if you think something looks like a 90-degree angle, if you think this looks like a 90-degree angle, you probably should assume that, okay? Never assume anything in that unless it's given to you, like it says 90 degrees or it has a square in it. Don't assume that it is. You guys know how to label triangles at this point? So vertices, or the corners, are capital letters. And the sides across from the vertices, so if this is corner C, and then the side would be directly across from it. The reason why you have to know that is you need to know when inputting the data into the formula, whether it's cosine law or sine law. So if you've never actually done that before, or labeled the triangle properly, you're going to have to get used to doing that. Okay, so this right here, this is sine law. And we usually only use 2 at a time. So lowercase letters represent the side of the triangle. So lowercase are sides. The uppercase is an angle measurement. Now, here's the deal. You can do it this way or you can do it this way. As long as they're the same, as long as all your angles are on top or your sides are on top, you just can't flip-flop them. This is the one I know. This is the one that I've always used. I don't really give ever a second option, but you can do it both ways. It's just a ratio. So sides are lowercase, capital letters mean angles. So, all right, so we use 2 at a time. So you can use A and C, A and B, B and C, but you're only going to use 2 at a time. All right, I'm so sorry. All right, you can use the sine law to determine an unknown side length in 2 situations. I don't know. Okay, you're going to figure it. I don't know how important this is. You can, so when 2 sides in an angle opposite of one of them is given, so side angle are known. For example, side angle, side angle. You can find the other side. I can't use Pythagorean theorem as well. Pythagorean theorem is only linked to 90 degrees. So Pythagorean theorems are out the window, and those basic trig formulas are out the window, unless you have a 90-degree. And then you can do it again when you have two angles on one side, so angle, angle, side. You'll figure it out. It will work. For 4.
Yeah.
Oh, okay. Yeah. I thought you meant Coral Thompson.
No, no. Yeah.
All right. So let's do some math. So I've been given this triangle. Obviously, I'm going to use sine law, so this is the sine law assignment. So if this is 63 and this is 60 degrees, what's my other angle? So this is the rule of 180. So 180 minus 60 minus 63 is my unknown angle. How much? 57. I'm going to write that in. Why did I do that? Well, 1 for funsies and 2 I might need it. So what kind of triangle was that? All the interior angles are less than 90. That's acute. So that's an acute triangle because all my angle measurements are less than 90. Okay, so we're looking for side B. Side B. So side B is that side of the triangle because it is directly across from angle B. So this is side B. So this is why you need to know how to label a triangle correctly, because you need to know how to do it. Okay, so what we need is we have, I call them sets. So I have this complete set. I have an angle and it's matching side line. I need that set. The other set I need is going to be B because I am trying to solve for side B. I don't care about side A. Well, maybe I do care about it, but not for this question. So I'm going to set it up. So I don't care about side A. I just said that. So I have side C over sine of C. Have to enunciate. I'm trying to find side B, and I have the angle of B. So that's the ratio I'm going to use. So I pulled the two out that I need. You're going to get letters that aren't A, B, C. It doesn't matter. They could be X, Y, Z. It could be K, A, P. It doesn't matter. Just pull out the one that you need. You do not have to write the sine formula all the time. I'm just writing it so we get used to it. So I'm going to fill in what we know. Side C has a measurement of 7. Angle C, so that would be sine of 60. And again, really make sure that that calculator is in degrees because this will screw you up if it's not. Side B, I don't know, that's what I'm trying to find, but angle B is 63 degrees. I don't have to put units and measure it until the end. Okay, so two fractions separated by an equal sign. That's what I can do. Cross multiply. Okay, we only do cross multiplying when there is an equal sign between two fractions. So I'm going to highlight, or I'm going to multiply those two. And so that's going to give me 7, the bracket here, sine of 63. And then I'm going to multiply, on the edge. Multiply those two. So that's going to give me B and sine of 60. All right, so I'm here. That's exciting, but I haven't solved for anything. And I don't do my, like, I don't put these into decimals right away because you should be using all your decimal place values. So I don't bother to do that right away. So I want B by itself. So the opposite operation is to divide by sine of 60. Divide by sine of 60. So those cancel each other out, which is nice, so then we would just be on this side. And I can do this all in one go in this calculator, but I'll put the decimal places so you can see it. Good, I'm in these, this is good, so sine 63 is 0.8910065242 all over 60, which is 0.6025438. Okay, so order of operations, I gotta do what's on top first, so I'm gonna do this multiply. You might be able to do this all in your calculator, and if you can, do it. Go 7 times sine of 63. The notes are right there. Did you grab them? The notes are just on the edge of that table. My numerator is going to be 6.23. Oh, that's supposed to be a 6.237045669, and I'm going to divide it by 0.8. And in my calculator, I'm going to hit divide by sine of 60 because I don't have time. I like to return all those decimals. So B is equal to 7 point, and did it say what we were rounding to? It doesn't say, so we're going to assume 2 decimal places. So 7.20, and my units of measure is centimeters. Leaving that unit of measure off is going to cost you half. Yeah. Pardon? Probably for rounding error, and sometimes that happens. Right, so if you don't use all the decimals, that's going to cost you a half mark once on your provincial exam. So rounding kind of matters. It definitely matters. Okay, this one, using the given triangle, solve for side length P, which is already highlighted here. So I don't have a matching set of information. I have a side, but I have no matching angle. Okay? But that's easy enough to find. How would I find angle A? Angle A. What do you volunteer angle that up to? 180. I like crowd participation for things like that. So angle A. 62. So this angle here is 62. So now I have my matching set. So this A is my matching set. You always need that set that has both the side and the angle in it. And then the other one obviously is going to be this one because I need to solve for side B. So now this is going to be A over sine of A equals B sine of B. Luckily, everybody's doing ABC, so this makes it easy. So A is 5. Angle A is 62, which we found. B, I don't know. And sine 57. So that rule of 180 comes in handy. You don't have to do any weird trig ratios or find side C and then find side A. So don't waste your time. Just do a subtraction to get that angle. So I'm going to cross multiply. So I'm going to have 5 by sine of 57 equals B times sine of 62. I want to get B by itself, so I'm going to divide by sine of 62. Divide both sides by sine of 62. So those are gone, leaving me with just B. I'm going to do this all in one move in my calculator. times sine of 57. I'm going to hit enter. And I get 4.19. I'm going to divide that by sine of 62. And that's going to give me 4.75 centimeters. So I'm not sure if you guys can do it all in one move in your calculator. So try that out. Make sure you can actually do it. That will make a difference. All right. Okay, word problem. Not super hard. I'm going to do it by the words. There's probably a lot more words than needs to be. Elliot's family owns a house. I should say on again the river in Newfoundland. Their closest neighbor's house is 2.5 kilometers away. So Elliot's house, neighbor's house. You may have to draw these triangles. They may not always be given. In this case, it was. A surveyor uses theodolite to measure the angles between the houses nearby communication tower and shown in the diagram. There's the communication tower. He's measured those two. Use sine law to determine the distance from Elliot's house to the communication tower to the nearest tenth of a kilometer. Okay, so tenth of a kilometer. That means I'm going to one decimal place. And when I look at this, so I'm going from Elliot's house to the communication tower. So this is what I need to find. So a direct line there. Okay, that's exciting. What am I missing? I don't have any sets of data. I'm missing an angle. Because I have this, but I don't have this, but it's easy enough to find. So I'm going to call this side C for communication tower. And you guys know that this little, if that comes right in front of a letter, that just means the angle sign. It's a little bit different than a greater than or less than sign, but I always draw the exact same. So 180 minus 80 minus 65 is going to give me 35 degrees. So now I have my matching set. So this one's 35 degrees. So that's my matching set. And the other one that I'm going to use. So even though it's Elliot's house to the communication tower, really, I'm going to use the angle at the neighbor's house to find this one. People get like the language screws people up, but it doesn't really matter. I know I'm looking for this side of the triangle. Just because the angle's at Elliot's house, it really doesn't matter. So I have to use the neighbor's angle to find Elliot's side. These are things that I find people kind of screw up every now and again. So we had 2.5 kilometers over sine of 35. That's my matching set. I always put the matching set first. I don't know why, but I always do. It's up to you guys what you want to do. X is the distance I don't know, and this is going to be sine of 80. So I'm going to cross multiply. So I have 2.5 times sine of 80 equals X times sine of 35. This is the end of cross multiplying. And we don't ever really pause here and say, okay, we've cross multiplied. We've got to do more math to get what we want. So now this is dividing by whatever coefficient is in there. So today, we are only working on finding sides. On Friday, we'll work on finding angles. So if you're wondering if we can do that, we can. So again, we can do it all in one action in my calculator. And I'm rounding to a tenth of a kilometer. So that's going to be 4.3. Oops, 10 on the wrong side. Too early. 4.3 kilometers. Sometimes diagrams won't be drawn to scale. Okay, so don't freak out if this is 4.3 and it looks the same length as 2.5. Sometimes the diagrams are drawn to scale. On your provincial exam, it will say right beside it, diagram not drawn to scale. So that's pretty standard that we have our time making 3 pictures for you guys. So that's sine law.